Hello, how is everybody? Today we're going to be talking about combining forces. Now, by force, I mean a push or a pull. There are two types of forces, right? A push and a pull. Now, a force is a vector, meaning that it has both a magnitude and a direction. A vector is something like velocity or acceleration, and unlike speed, because speed does not contain a direction. The unit of magnitude that we use for combining forces, or forces in general, is the Newton. The Newton, right? And essentially what the Newton is, you might want to memorize this. It is the kilograms times mass, or meters per second squared. Sorry about that. Right. And so we have two types of forces, contact and non-contact. An example of contact would be what I mentioned earlier, a push or a pull. But we also have non-contact, as the name implies, it's not touching. An example of non-contact force is something like gravity or an electric charge. And so I drew this box right here. It might not be very well drawn, but I also have two arrows here. And this is the central message of the video. We have two forces, two unbalanced forces going in one direction. We're gonna have an adding of these forces. Let's say that these forces are about 40 newtons, as we know here. 40 newtons. This is going to be a net force of 80 newtons on the object. By net force, don't be confused. All a net force is the overall force that is on an object. In this case, it would be 80 newtons on this box because of these forces acting upon it. And some rules about combining forces is that forces in the same direction add together. However, therefore, forces in the opposite direction subtract. Okay, let me show you an example about subtraction. I'm pretty sure you see this in everyday life. Say we have something very heavy. I'm going to draw this circle. Imagine it's something very heavy. And let's say you are pushing it really hard. You're pushing it like, I don't know, 100 newtons. But your friend, he's pushing it about 110 newtons. And although you're trying really hard, science is your disadvantage right now, because your friend is going 10 newtons more than you. And so we'll subtract here. We'll have 110 minus 100. I'm sure you can do this in your head. The answer is 10 newtons. So we have a net force of 10 newtons to the left. And this is what I mean about a direction. Always when talking about forces, we're going to have a magnitude that it goes to, in this case 10 newtons, and its direction, which in this case is towards the left. See you in the next one.